In a previous video, I mentioned that we were going to look at rational and irrational numbers in a bit more detail. We established that both rational and irrational numbers are real numbers. That is, that they exist on a number line. However, the difference between rational and irrational numbers is that rational numbers can be expressed as a fraction or ratio of one integer over another, a over b, where b cannot equal 0. Irrational numbers cannot be expressed as a ratio of one integer over another. Let's begin by exploring rational numbers a bit further. Here are some fractions: a half, a quarter, 3/8, and 23 over 40. Notice that in each case the decimal equivalent ends. We can see that a half is equal to 0.5, a quarter is equal to 0.25, and so on. These are called terminating decimals. So if you saw a terminating decimal, you know that this is a rational number. Now let's look at these fractions. You're probably familiar with a third and 2/3. A third is equal to 0.333333 and so on. 2/3 is equal to 0.66666666 and so on. These are called recurring decimals, where a digit or group of digits after the decimal point produce a repeating pattern. With 0.3 recurring, because it is 3 that is repeating itself, I can write it like this, by putting a dot over the 3 to signify that the 3 is repeating. I can also do the same for 0.6 recurring, by writing 0.6 with a dot over the top. I did briefly look at this in a previous video when we were looking at fractions, decimals, and percentages. Here are some other examples of recurring decimals. If we look at the fraction 4 over 11, the decimal equivalent is 0.36363636 and so on. Again, we have a repeating pattern of 0.36 recurring, and we can write it like this. Notice that for 5/7 we have 6 digits that are recurring. So you have to be careful when determining whether a decimal has a repeating pattern or not. So any recurring decimal is a rational number. Now let's look at irrational numbers. I gave 2 examples of irrational numbers in the previous video, pi and the square root of 2. Let's look at their decimal equivalent. When looking at the decimal in each case, notice that there is no repeating pattern. There are no recurring digits. Decimals like this cannot be expressed as a fraction or ratio of one integer over another. They are therefore irrational numbers. Here are some other examples of irrational numbers. So, for example, if we're looking at the square root of any prime number, these are all irrational. Logarithms of prime numbers with a prime base are also irrational, but let's not get too worried about these. Also, if we add a rational number to an irrational number, we will produce an irrational number. For example, 5 add the square root of 2. And if we multiply a rational number by an irrational number, we also produce an irrational number. So for example, 3 multiplied by pi, or 3pi. So to summarise, if you see decimal numbers that terminate or have a recurring digit or group of digits, these are rational numbers. And if you see decimal numbers that don't terminate and there is no repeating digit or group of digits, then these are irrational numbers. So there's a brief look at rational and irrational numbers. I'm currently working on a short video looking at pi, with the intention of this being the next video. So keep an eye out for that. That's it for now. I hope you found this helpful, and thank you for watching.